Let's go ahead and talk through the exterior angle theorem here with triangles. So what we're going to see is we're going to see a triangle given labels for its vertices or the vertex points, and then there's going to be a line extended through one of the points. So for this case, as it says here, it says triangle ABC is shown below. Side AC is extended through point C to point D. So extended through point C to point D. Now, the exterior angle theorem states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So if we add A and B, it has to equal this exterior angle D. So let's take a look at a couple examples down here. So for number one, we're given triangle PQR with side PQ extended through point Q to S. So if we repeat that, we have triangle PQR, and then we have PQ extended through point Q to S. So if angle P is 42 and RQS is 78, what is angle R? So we're given 42 for this angle, 78 for this angle. This is the angle we're trying to find here. So we have to set it up just like we said. So the two opposite angles from the exterior angle added together equal the exterior angle. So 42 plus X equals 78. Our angle R is equal to 36 degrees. Let's go through another example. So sometimes we might have to draw our own picture here, and it helps out if we draw it flat, meaning if we draw the extended side flat with the page. So angle F is equal to 42 degrees and angle FGH. And then it says that there's an exterior angle at vertex H, and that has a measure of 104 degrees. So I draw my triangle FGH first, FGH, and then I extend my line for an angle at vertex H. Extend here, and I label 104 and 42. So I'm missing this angle here. I'm looking for the measure of angle G. So 42 plus X is equal to 104. And I solve for X here and get 62 degrees. So it's the same thing over and over again. We're taking the exterior angle and setting it equal to these two added together. So if we take a look at number 3, we're still applying the exterior angle theorem, except there's a little bit of algebra involved. So nothing changes. We still have these two angles added together is equal to the exterior angle. So if we set that up to find angle C, which is this here, we do 4y plus 7y plus x, so these two added together and set equal to 116. When we solve for y, we get 10. And then our main thing is we always plug back into what we're looking for. We're looking for angle C. We plug into 4 times y, and we get angle C is equal to 40 degrees. For number 4, we have to check on the truth of a claim from a student. So Maya claims that angle 3 plus angle 4 equals angle 1, as shown in the triangle. Which equation explains why Maya's claims must be true? Well, let's first go right to our choice here. So our choice that's correct here is angle 1 plus angle 2 equals 180. Yes, that's true. Those are two angles along a straight line, so definitely true. And then the other statement says angle 3 plus angle 4 plus angle 2 is also equal to 180, and that's true because those are internal angles of a triangle. So both those statements are in fact true. Now let's go ahead and check the other statements and see why they're false. So the third one says angle 1 plus angle 2 is equal to 90. We just said that's not true because those are two angles along a straight line, so we debunked that right away. That's not a good choice. Choice 2 says angle 1 plus angle 2 equals 180. That works. But the other choice, angle 3 plus angle 4 equaling 180, is not true because we need 3 angles in a triangle to add a 180. That's only 2 of them. And then choice 1, we already discussed that 1 plus 2, or angle 1 plus angle 2 is 180. And then angle 3 plus angle 4 doesn't necessarily equal 90 just because it's angles on the inside of a triangle. We don't know enough information to say that. So our only choice that works is choice 4. For number 5, we have another diagram here with an extended exterior angle. So triangle ABC extended through point C to point D. We're given labels for angle B, angle A, and angle C. All we're doing here is setting up our equation. So 40 plus 2x is equal to 3x. I do that here and I solve and I get 40 equals x. So now when I plug that back in, I plug back in x equaling 40. So I get 3 times 40 is 120, and I'm looking for angle C, or ACB here. So I have to subtract 120 from 180 because it's 2 angles along a straight line. So 120 from 180, and that's how I get my 60 degrees. For number 6, this is one where I have to draw my own picture. So triangle ABC, and then we have AB extended through point B to point D. I label what I'm missing. I'm given that angle ACB and CAB are 2x and x plus 30 labeled in the picture. And then I have my exterior angles equal to 5x minus 50. The way I solve is the same thing over and over again. The exterior angle is equal to the 2 opposite angles on the inside of the triangle added together. When I set that up, I get x is equal to 40. That's all I needed because the question finished off with finding the value of x. Now moving on to number 7. For number 7, we have the same situation here. It's repeated over and over again. It's the main theme is to use the exterior angle theorem. So again here, if you look at the work, all we're trying to do is solve for angle CAB. So I do the same thing. I add my exterior, or I add my opposite angles to the exterior angle. So angle A plus angle C equals the exterior angle. Solve. I get x is equal to 25, and then I plug back in to angle CAB, which was x plus 40, and I get 65 degrees. For number 8, I have to fact check some statements here. So let's look. It wants to know which of the following statements must be true. So I'm given that angle NGS is equal to 80 degrees. Well, let's check. Why does number 1 not work? Is angle NGS equal to NGA plus angle A? So NGA and angle A, that's not true. The correct answer would be this angle plus this angle. That's not the exterior angle theorem. So wrong pair of angles were given, so not choice 1. Angle A equals 80 degrees. That's not true either. We never said anything about that angle being congruent to this one. Choice 3. Angle A is less than 80 degrees. Well, yes, that has to be true because these two added together have to be equal to this one. So if this was 80, sorry about that. If this angle was 80 degrees here, this would have to be 0 degrees for this to work. It has to be 80 plus 0 equals 80, which is impossible. You can't have a 0 degree angle. So choice 3 is our only option that works here. For number 9, we have to draw a diagram just like we've been doing. We extend through our point. So AC is extended through C to D, and I label my missing angles. And I set up and solve. The 2 interiors, or the 2 opposite to the exterior angle, equal the exterior angle. I solve, I get x is 29. That's what I was looking to find. Same thing goes for 10 and 11. If you'd like to pause the video and take a look at the work, this is quite repetitive. I think you get the concept of it now. We're using the exterior angle theorem every single time, and we're deciding where we have to plug back into based on what the question is asking. So if we move on, so 10 and 11, like I said, exterior angle theorem always. So let's fact check number 12. 13, 14, and 15 are all exterior angle theorem questions. If you want to pause the video and take a look at the answers and the work, you can go ahead and do so. But it's the same repetitive process of adding those 2 angles and setting it equal to the exterior angle. But to quickly go over number 12, we have to draw our own picture and check a couple facts out here. So, given triangle ABC with AC extended to point D, so we'll redraw the diagram here, which of the following statements must be true or not have to be true? So we're looking for something that's false. So if I look at number 4, angle BCD, so this angle here is greater than angle BCA. That's the only one that's true because this angle here can be bigger than this one. It has nothing to do with these two, right? This angle can be acute, and this one could be obtuse. It could kind of look like a shark fin here. It doesn't always have to be that standard picture we're used to like this up here, where this angle is obtuse and this angle is acute. So it can be a little different. So that's the only one that works out of all of these.